Hello, in this video we'll basically continue our discussion about requirements analysis good practices, not best practices, good practices. So again, in fact, we discussed about the first two in a previous video, and now we're going to discuss the rest. Let's start with this one, creating user interfaces and prototypes. So prototypes particularly, they're quite powerful, in fact. So what are they? A simplified partial version of the system. Obviously everyone knows about it. What's the purpose? Main purpose is in fact to resolve uncertainties and to gather as much knowledge about what users would like to see as a feature, as a solution, as a part of the solution, and to do that early in the development life cycle. So it is quite powerful, as I said, to reveal inconsistencies or incompleteness in your requirements. So use them as much as possible. And also holds for the user interfaces, obviously. I mean, the user interfaces might even be considered as a form of prototypes as well. And speaking of forms of prototypes, I mean, prototype is not necessarily something that's really working. I mean, a paper sketch of a user interface might as well be considered as a prototype, but of course you might as well come up with highly advanced prototypes where in fact these prototypes might even become a part of the solution. So there are different types. We'll come back to that later on in a later video, essentially. So what are they good for? Quite effective in eliciting requirements, elicitation as well, as I mentioned, but also in the analysis, and particularly quite effective when the users are unclear about the functionalities, about what they really want from the systems. Real inconsistencies, incompleteness, I already mentioned about that. Strong involvement of users experimenting with the early system versions, fast feedback and quick adoptions. Obviously these are the kind of positive things or pros of prototypes. So I'll not go too much into details of the prototypes here, because we will discuss more particularly about the types and strength and weaknesses, strong points and weaknesses of prototypes later in the requirements validation and verification module. That was the third good practice. So use prototypes. Prioritize and negotiate. So prioritize basically meaning, or let me start with this discussion. So if you ask a user about the priority of a particular requirement, very, or let's say in many of the cases, you would see that like, hey, that requirement is high priority, and that one as well, and that one as well. So people will find it very difficult to have a ranking about the priorities. Obviously there will be core ones and the less important ones, but if you leave it just to the hands of the users, they would probably rank everything as the highest priority. So, and that's not realistic, and that shouldn't be the case anyway. So what we need to do, as a good practice, is to apply an analytical approach to determine the relative implementation priority of product features, use cases, or individual requirements. So we should be as objective as possible, or we should use techniques that would give us to properly prioritize the requirements. And these are quite important features, because particularly nowadays, you just don't go with a completely finished version of a product or a service. You basically first prioritize the core ones and work on them, put your effort on them, release them, and then update and improve and come up with or add new functionalities, improve the existing ones, and so on. So it's a process that continues, and prioritization of such features become very important. So, and usually, in fact, I mean, if you're talking about a setting where you have the business analysis on one side and the users on the other side, the prioritization usually involves negotiation. Okay, so you negotiate, so you give and take, kind of a negotiation. So as I said, if you leave it to the users, everything will be highly important, and that shouldn't be the case. So you should just sacrifice some things, and then as a response you have to give something, let's say as a remedy and so on. So so you need to find some compromise which all the stakeholders can live with. That's negotiation. And obviously this negotiation is influenced by the political concerns, project-related considerations, personalities of the people involved. So sometimes you might get a very lenient business analyst who says yes to everything. Believe me, that's also a recipe for a failure. You can't say yes to everything, then your team would really hate you, designers and programmers. So it's also a skill that you have to, let's say, you have to have some sort of an experience and also expertise later on that you need to develop your skills about negotiation. So how to say no to some features, but as a response to say yes to the other ones. Prioritize, negotiate. Number 4. Number 5. Create a data dictionary and data models. So it is extremely important to communicate in the best way possible your requirements, and this requires a kind of a data, or let's say a kind of a common terminology that you use during communication. So you need that kind of a data dictionary or data models, if you like, that would tell us exactly what type of a term means what. So this is rather simple, but a very important thing to ensure. We can use data dictionaries. Data dictionaries are all definitions of all data items associated with the systems. Again, it enables everyone working on the project to use the same consistent definitions for all these abbreviations and also these terms. There are different ways. So one practical way is to use something like this. You say there's this kind of a topic or a business object called person. You can define what a person means, and then you say, oh, okay, these are the kind of attributes that define, that characterize it, a particular or that particular business object. Okay, that is what you can do. But you may as well use some graphical notations, which are a little bit more formal, if you like. In that, I mean, particularly when it comes to ER, enterprise entity relationship or UML class diagrams, they're a little bit more formal, and sometimes it depends on how high level you are at the user level, at the analysis or at the user level you may skip the class diagrams, but at the solution level, yeah, you must definitely have one. So, I mean, at the user level, you may skip the class diagrams or ER diagrams and you may stick with a data dictionary, but at the solution, eventually you have to create a data model for your system anyway. Okay? So, I mean, this is an enterprise. I mean, I'll suggest the same thing to you. Here in this course, we don't have time and nor intentions, I must say, to teach you how to use a particular diagram or a notation for something. I think you are grown-ups to learn such things on your own. So the more important thing is how to combine these things, at least as far as this course is concerned. More important thing is to know exactly when to use what, combining your skills in the best way possible. That's more important for us in this, again, within the scope of this particular course. So if you don't know how ERs work, for instance, or how class diagrams work, that's another example, that's a class diagram, then you'd better learn these things. So there are numbers, just Google them, you'll be able to find perhaps too many sources, I must admit, but just pick one, basic ones, and learn how these work. Okay, so this is just an example that shows, for instance, these 3 business objects, their attributes and how they are related to each other. Okay, so the product or the customer, and what the customers, how can you identify a customer? A customer is identifiable through customer numbers. A customer has a name, an email address, and one customer can make many orders and many order, and one order can have many products, and one product can appear in many orders. So the relationship includes this M2N or multi M&M relationships, and so on. Just check how this thing works. Very close to the in fact class diagrams, which so one note here about the ER diagrams. So this is, for instance, quite an acceptable level of detail at the user level, or even at the requirement solution level. This one is a little bit more, let's say, advanced, and you would see that kind of a representation suiting perhaps better in the design phase. Okay. But it's, of course, I mean, it's not black and white, so you might as well see such a kind of representation, use of ER diagrams in the requirements phase as well. But yeah, I see that it's a little bit like one step before the database, so yeah, okay, you can use that. But this one is fine as well. Have one, that's for sure. This is a class diagram. So again, I'm not going into the details of this thing. So it says class diagrams are very much similar to the ER diagrams. It also shows the business objects, if you like, that will be maintained. But it also has, particularly towards the design, it has the methods and so on. So it's a design element as well. At the requirement stage, you should not have these kind of method descriptions in the class diagrams. At the requirements phase, these are not needed. These are not just needed, sorry, you shouldn't have that. Just to clarify that. Okay, here it says like there's this person object, and he or she has some attributes, name, phone, email, and a student is a person, and a professor is also a type of persons, and then each class here, or object if you like, each object has specific attributes as well. So in this, if you are a student, then you also have a student ID and an intake here, and then if you're a professor, you also have an employee ID, position, grade, and so on and so forth. And each person has an address. Just an explanation. Check how it works. Okay, once more. Sixth one, analyze interfaces between your system and the outside world. So we mentioned about the kind of context diagram that shows that relationship in one way, but that's a very high level relationship. So here we refer to a deeper understanding of how that interface works. We can talk about three forms of interfaces. One form is the interface that your solution IT system would have with the users, with its own users, user interface. Then we should mention about the interface between your system and other type of systems, software systems. And that's a very typical thing in business systems, all the ERP systems, CRMs, and so on, as they're interconnected and they exchange a lot of information. You have to have a very good understanding of that. And also, if your system should somehow involve some hardware, if you're talking about a mobile application, rarely the case. But if you have something like this, then yeah, definitely you also have kind of interface with the hardware systems, sensors and so on as well. So three forms of interfaces. You have to define how that interface works, what kind of data is exchanged between your system and outside world. And when we mean outside world, we're talking about users, other software systems, and hardware. 7, and final, allocating requirements to subsystems. If your solution system, if your IT system is a large system, which also involves some, in many cases, like a hardware, like traffic control system, okay, nuclear reactor control system, or air traffic control system, and so on and so forth, which involve hardware and software at the same time. You just can't go or you can't just start with elicitation. Or let's say requirements analysis, not elicitation. You have to start with elicitation anyway, but the requirements analysis, because you first have to have a broad understanding or high level understanding of what the system is in general, what big components, what chunks of components does it have. and what would you expect from these chunks of big components of your system to do. So basically you have to first make a very high-level architectural design of your system first, and then allocate the high-level requirements, features to those subsystems, and then you should start building your doing your or taking these high-level system requirements as input. Remember the module requirements, basics, and elicitation that we mentioned about different types, and we also mentioned about system requirements, and that's what we mean here. So it's a high-level representation of a feature. You take that feature and dig down into the details, do the elicitation, do the analysis and specification, as we'll see later on. So that's also a good practice. So just don't take the entire thing all at once. First, if it is large system, then build it into pieces, and then go with the requirements analysis. Okay. So recap: we have 7 requirements practices, from modeling the application environment, context, scope, to modeling the requirements, interface, developing interface sketches, UI sketches and prototypes, prioritizing, negotiating, creating data dictionaries so that you have a common kind of dictionary that you can refer to, analyzing the interfaces between your system, your user interface, software interface, and hardware interfaces, and allocating, if you're talking about a large system, allocating requirements first to subsystems and then continue. These were the good practices of requirements analysis. Yeah. So good luck, I would say, and see me in other videos.